Welcome you all. From the 7th chapter integrals, we have completed exercise 7.1. By applying inspection method, we found integrals of the given function. In exercise 7.2, by applying substitution method and then inspection method, we solved 5 questions. We found integrals for the first 5 functions. Now we will solve the 6th one. Sixth question, integral of square root of ax plus b with respect to x. We know that square root of x is equal to x to the power 1 by 2. Right? So here we have x to the power quantity, a number. So if you think this as x to the power n, now by inspection method we have a formula, right? Integral of x to the power n will be equal to x to the power n plus 1 by n plus 1 plus constant of integration. So if we are able to bring this in the form of x to the power n, then we can, by inspection method, we can apply the formula. So first we have to do the substitution for this linear term, bring this in the form of x to the power n, and then we will apply the formula. So let ax plus b is equal to t. Differentiate with respect to x. So if you differentiate ax, you will get a. If you differentiate b, you will get 0. So this will be dt by dx. So we have to substitute for dx. So dx will be equal to dt by a. Now let us check whether all x is now in the form of t. So this entire ax plus b is t. And dx is also equal to dt by dx. So this is completed. So all x is in the form of t. The substitution is also correct. Now let us write there integral of square root of t. In the place of dx we will write dt by a. So we know that 1 by a is constant. So we will bring it outside. Integral of square root of t can be written as t to the power 1 by 2. So now this is in the form of x to the power n form with respect to t. So 1 by a. So integral of t to the power 1 by 2 will be t to the power 1 by 2 plus 1 divided by 1 by 2 plus 1. Since we have done the integration, we will write plus c. Now this implies 1 by a, t to the power of half plus 1 is 3 by 2 divided by 3 by 2 plus constant of integration. Now here we have a complex fraction. So when you have 1 divided by a by b, we will write this as b by a. Right? 1 divided by a by b. So we will write this as b by a. So this is complex fraction. So here we have complex fraction. See, 1 divided by a by b. So this we will write it as b by a, t to the power 3 by 2 plus constant of integration. Now this implies 2 divided by 3 by a, t to the power 3 by 2 plus c. So now we have simplified. Now we will substitute the value of t, which is ax plus b. So therefore integral of square root of ax plus b with respect to x is equal to 2 by 3a. So in the place of t we will write ax plus b to the power 3 by 2 plus constant of integration. So this is the required integral of the given. Now let us solve for the 7th one. Integral of x into square root of x plus 2 with respect to x. Now there is a direct formula for this. So when you have integral of ax plus b to the power number, any quantity, you will write it as 1 by a. 1 by a into ax plus b to the power n plus 1 by n plus 1. So this you will only apply when n is not equal to minus 1. So even if you have fraction or any other positive value you can apply, but not for minus 1. Okay, so when you have minus 1, the formula will be 1 by a into log of modulus of ax plus b plus c. So this you can remember. So integral of 3x plus 4 will be 1 by 3 into 3x plus 4 to the power n plus 1 by n plus 1. Now let us take x plus 2 is equal to t. Now if you differentiate this, you will get 1 is equal to dt by dx. So this implies dx will be equal to dt. So now dx is in the form of t, x plus 2 is also equal to t, but what about x? For that, in the substitution itself, we can write x is equal to t minus 2. So now this is also in the form of t, this is in the form of t, and this is also in the form of t. So therefore, we will write integral of t minus 2 into square root of t with respect to t. So this implies integral of, now let us multiply t into root t with respect to t minus integral of 2 into root t with respect to t. Now this implies integral of, so this is t to the power 1, t to the power 1 by 2 with respect to t minus 2 into integral of t to the power 1 by 2 with respect to t. So why we are writing in this form? So that we can bring in the form of x to the power n and we can apply the formula. Now this implies integral of t to the power 1 plus 1 by 2 will be 3 by 2 with respect to t minus 2 into integral of t to the power 1 by 2 with respect to t. So now both the terms are in the form of x power n. So this implies t to the power 3 by 2 plus 1 divided by 3 by 2 plus 1 minus 2 into t to the power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus constant of integration. Now this implies t to the power of 3 by 2 plus 1 is 5 by 2 divided by 5 by 2 minus 2 into t to the power half plus 1 is 3 by 2 divided by 3 by 2 plus constant of integration. So now this implies, so again we have complex fraction. So 1 divided by a by b will be b by a into t to the power 5 by 2 minus, so this will be 2 by 3. So 2 into 2 will be 4. 4 divided by 3 t to the power 3 by 2 plus c. So therefore, integral of x into square root of x plus 2 with respect to x is equal to 2 by 5. So in the place of t, we will write x plus 2 to the power 5 by 2 minus 4 by 3 into x plus 2 to the power 3 by 2 plus constant of integration. So this is the required integral of the given function. Question number 8. Integral of x into square root of 1 plus 2x square with respect to x. So here we have a quadratic term under the square root. So we have to substitute 1 plus 2x square is equal to t, and then we have to substitute for x as well as for dx, so that all the x will be in the form of t. So let 1 plus 2x square is equal to t. Now we will differentiate with respect to x. So if you differentiate 1, it is 0. If you differentiate 2x square, you will get 4x is equal to dt by dx. So dx will be equal to dt divided by 4x. Now if you observe carefully, here we have x into dx, right? So we will keep x here. X into dx is equal to dt by 4. So now entire x into dx can be written as dt by 4, and this is in the form of t. So all the x is in the form of t. So integral of square root of t into dt divided by 4. So let us take constant outside. 1 by 4 into integral of t with respect to t. So this implies 1 by 4 integral of t can be written as t to the power 1 by 2 with respect to t. Now this implies 1 by 4 into, so integral of t to the power 1 by 2 is x to the power form of x power n. So we will apply this t to the power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus constant of integration. So this implies 1 by 4 into t to the power 3 by 2 divided by 3 by 2 plus c. Now this implies, now again this is in the complex fraction form. So 1 by 4 into 2 by 3 into t to the power 3 by 2 plus c. Now this implies, so 2 times 1, 2 times 2. So you will get 1 by 6 t to the power 3 by 2 plus c. So therefore, now we will write t equal to 1 plus x square. So integral of x into square root of 1 plus 2x square with respect to x is equal to 1 by 6 into 1 plus 2x square to the power 3 by 2 plus constant of integration. So required integral.